All right, scholars, we're going to continue with our Module 5 notes. Today we'll be looking at Module 5, Lesson 13, Multiply Mixed Number Factors. Now, we're going to be connecting this to the area model. We're going to talk a little bit about the distributive property, probably very little in class together. For right now, what we're actually going to do, since this is such a continuation of the things we did in 512 and 511, I'm actually going to just dive right in to do some problem solving with you. Oh, forgive me. I forgot our Roman numeral. 10, 11, 12, 13. I was so excited to dive in, again, to that problem solving. I am going to give you a problem. This particular word problem is actually from your Learn book. It's on page 93, so I'll include that. Learn, page 93. If you want to get your book out and open it so that you can read along from there, you can. Otherwise, I'm going to give you kind of an abbreviated version right here. Okay? So, a family wants to put in new flooring. A family wants to put in some new flooring. That's what Mrs. Landre wants to do. She wants to change the flooring in the bathroom. Now, for this particular family, the room they're putting flooring in, the room is 6 1/2 feet by 7 1/3 feet. Now I'm going to break this word problem apart as we go through. Like I keep saying, it's on page 93 of your Learn book. You can see I'm abbreviating slightly so you don't have to copy quite so much. But the first sentence has the same information. 6 1/2 feet by 7 1/3 feet. Now really, before I read the rest of it, before I'm even worried about the rest of it, I can find the area because I know that area equals length times width. Now, maybe I take my length times width, I draw out a rectangle, do the whole thing. But really, I don't have to do that right this second. I can just say 6 1/2 feet. I draw one of my little arrows. Come on, arrow. 6 1/2 times 7 1/3. Now, I've had a number of students ask, can we do it the other way? Mr. Landre, you keep saying length is longer. Shouldn't 7 1/3 go first? Commutative property of multiplication tells us it really doesn't matter. It doesn't matter. Since we're multiplying them together, the order, not super important. Now, 6 1/2 times 7 1/3, I want to take those mixed numbers and turn them into improper fractions. 2 times 6 is 12. 12 plus 1 is going to be 13 over 2 times 3 times 7 is 21 plus 1 is 22 over 3. Denominators are the same. I'm going to make sure I did that. 2, 2, 3, 3. Okay. Now 13 and 3, they both have that 3, but unfortunately they cannot be divided by 3. Specifically 13 cannot. But 2 and 22, those will be a little more helpful. Those share a common factor. I can divide both of them by 2. 2 divided by 2 is 1. 22 divided by 2 is 11. So now I've got 13 times 11 over 1 times 3. 13 times 11, that would be like 13 times 10, so 130, plus another 13. So that would be 143 over 3. Ugh. Can't do a whole lot with that. So, let's do some long division. 143 divided by 3 Remember, numerator divided by denominator. 3 will not go into 1, but it will go into 14. It'll go in about 4 times, not quite 5. 4 times 3 is 12. Subtract that out, get our difference, bring down the 3. Okay, 3 is going to go into 23 about 7 times. 7 times 3 is 21. All right, so kind of a lot of division there, but we end up with an overall area of 47, and 2/3. 2/3. Now, we originally were working with feet. Feet squared. Now again, I did this before even really finishing the problem. This is not what they're asking for at the end, but if they're going to tell me that the room is this by this, and I'm putting in flooring, I'm covering it, I'm thinking area. I need to find the area. So let's go ahead and continue with the problem. Okay. The next part of the problem, it says the tiles, while I'm copying this, you can enjoy the sounds of my children screaming in the background. The tiles come in 12-inch squares. Okay, so one tile is going to be 12 square inches. Now, 12 square inches. 12 inches is equal to 1 foot, right? That's convenient. So these 12-inch tiles are really 1 foot. They're 1 square foot tiles. So my area can help me figure out how many of these I need. I'm going to need 47 square feet, right? And then another 2/3 of a square foot. Do you think Lowe's or Home Depot will sell me 2/3 of a square foot? No. I'm going to go to the hardware store, the home improvement center, and they're going to ask me to buy that 48th tile. I don't get to buy just 2/3 of it. That'd be nice, but whatever. So even though the actual area of the bathroom is 47 2/3 feet squared, I'm going to end up having to probably buy 48 square feet tiles, which means 48 tiles. Okay. So 47 2/3 feet squared, that's approximately equal to 48 feet squared, 48 square feet. Every tile is a square foot, so every tile is 1 square foot. That's nice. The family, and this is me kind of including the answer in with what I wrote earlier for the problem itself, okay? The family will need 48 tiles. Okay. So now we know what to do when we go down to the hardware store. I'm going to go back to my problem. Okay. The family wants to put in the flooring, 6.5 feet by 7 1/3 feet. The tiles they want come in 12-inch squares, 1 foot squares. What is the area of the bathroom? Well, we did that already. We did that first thing. But it then asks, if the tiles cost $3.25 per square foot, how much will they spend on the flooring? Okay, well, one tile is equal to 1 square foot. We worked that out already. Which means one tile, 1 square foot, is going to cost $3.25. Now, that sounds like a lot, but I mean, if you're buying a tile that's, remember, the size of a ruler, okay, This is about 12 inches right there. Can't even get it on the screen the whole way. It's a pretty large tile. So, one tile costs $3.25. We figured that because we have to round up, because they're not going to sell us a portion of the tile, the family's going to have to buy 48 of these things. So 48 tiles at $3.25 a tile will give us the answer. That'll tell us how much they will spend on flooring. Okay. How much will they spend on flooring? And again, this is the final question, the final part of the word problem, so that I'm writing out there. How much will they spend? I don't know, let's figure it out. I always like to put the longer number on top. Technically, this is smaller. It's 3 1/4, 3.25, 3 1/4. It's technically smaller than 48, but it has more digits, so I'll put it on top. Okay. We'll start with our 8. 8 times 5 is 40. Carry the 4. 8 times 2 is 16. 17, 18, 19, 20. Cool. Carry the 2. 8 times 3 is 24. 25, 26. All right. All done with the 8. All done with the 4. All done with the 2. We just kind of shade those out so they're not bothering us anymore. 4 is my next focus number, but before I start dealing with that, I'm going to put a spacer 0 down below, because again, this is not technically 4, it's 40. We're not going to talk about it that way, but mathematically speaking, that's what it would be. 4 times 5 is 20. Carry the 2 up above the next digit. 4 times 2 is 8. 9, 10. Carry the 1 above the next digit. 4 times 3 is 12, plus 1 is 13. Gotta make sure that those are lined up nicely. I missed my graph paper. Go ahead and add these together. The zeros, 6 and 0. 2 plus 3 is 5. Nothing plus 1. Now, they're not going to spend $15,600 on flooring. That is not correct. What we need to do is remember there are 2 decimal place values up here. 1, 2. So I need to jump over 1, 2 down below and put in my decimal point. Now that I've done that, I have the final answer. They will spend, make that look like a W, they will spend $156 and no cents. They will spend $156 and no cents on flooring. Yes, we're calling for Jackson right now for some reason. Okay, folks, we'll go ahead and stop here. The last few lessons have been a little bit on the long side. This one's not exactly short, but hopefully it's better. When I see you in class, we will continue multiplying mixed numbers together and working on problems similar to this, finding area with mixed numbers. If you have any questions, make sure you write them down. I will talk to you soon. All right, and Virginia's at the door. So thanks, ladies and gentlemen. I'll catch you next time.